Hello, excuse me. Hello, my name is Keshwani. There's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 918. Please turn to it. Page 918. And today is our lesson number 134. Let's see what we can do there. The two problems that you see in the second column, number 12 and 13, are the ones that we're going to do today. Yesterday, on day number 133, we did the two problems that you see in the first column, number 10 and 11. Number 12. We are told that x plus 3 over 2 is an integer. The question simply is, if that were to be true, then x must be, and then they give us 5 choices. Now the word that they use here is must. Then x must be, in other words, they're looking for something that has to be true all the time, not something that may be true. Sometimes we're not looking for then x may be or x could be. The question here is then x must be, and the very first claim they make is that x must be negative. Let's find out. A says then x must be negative. Is that true? All we have to do is see if you can plug in a positive number for x and see if it works. For example, if you plug in 1 for x, 1 plus 3 over 2 is 4 over 2, which is 2, which is an integer. All we are told is that this quantity has to be an integer. We just found out it's an integer, and it's a positive number, which means x does not need to be negative. B says, let's erase this part. B says x must be negative. So at this point, B says x must be positive. So at this point, all we have to do is plug in a negative number and see if it works. For example, if you plug in negative 1 plus 3 over 2, negative 1 plus 3 is 2, and 2 over 2 is also an integer. So as we can see, x does not need to be positive. Here we have a negative 1. And of course we didn't have to have negative 1. Instead of negative 1, we could have had negative 11, and it still would have worked. Negative 11 plus 3 is negative 8, and negative 8 over 2 is a negative 4, which is an integer. So x does not need to be positive. X could also be negative. B is not the answer. C says that x must be multiple of 3, which is pure nonsense, because we just saw that x equals to negative 11 works, x equals to negative 1 works, x equals to 1 works, and none of these were multiples of 3. So C does not work. D claims that x must be an even integer. Let's find out. X must be an even integer. If x happens to be an even integer, even plus 3, which is odd, even plus odd is going to be odd. If you add up an even number and odd number, you're going to end up an odd number. An odd number, any odd number, if you were to divide by 2, is not going to be an integer. Any odd number cut in half is no longer going to be an integer. D does not work. The only answer choice, the only claim that is going to be valid all the time is the fact that x, whatever it is, must be odd. Let's find out why, shall we? The answer is E. X has to be odd because odd plus 3, which is also an odd plus an odd is going to give us any odd number plus an odd number is going to give us an even number, and any even number divided by 2, it doesn't matter what the even number is, any even number divided by 2, because that's what even number means. Even number means that whatever the hell it is divisible by 2. So any even number divided by 2 is in fact going to be an integer, and that statement is true. X must be odd. X must be odd. The answer is E. Number 13. Number 13. In number 13, they give us this elaborate picture here. Let's see what we can do here. So here we have a small circle here. This is a cube. P, which is 3, 6, and here we have a large circle, which is S. Now this point Q that we see here and this point S that we see here better be the centers of the circle, because otherwise they will have no meaning whatsoever. These points could be just any old point on the diameters of the two circles. The only way they would have any significance is if somehow we are told that they are in fact the centers of the circles. Let's find out. In the xy plane above, the points Q and S are centers of the circle. What do you know? Which are tangent to the x-axis. As we can see, they touch the x-axis on one point. To be tangent means they touch it at one point, and this is a right angle. In other words, it's going straight down. It's a perpendicular. What is the slope of the line QS? Let's find out. We're looking for the line QS. The line QS is this line right here, Q to S. So in order for us to do that, we have to find the coordinates of point Q and the coordinates of point S. Let's put Q here. Point Q here will have the same x coordinate as point P, which is 3. And since the diameter, since we are told that Q is the center, where is my pointer? Since we are told that Q is the center, this distance that we see, because of the fact that it's going at a 90 degree, this distance is the diameter, which is 6. 6 is the diameter of the small circle, which means the radius of the small circle is also 3, which means the y coordinate of Q is 3. The Q goes from Q 3, 3 to point S, which has again the same x coordinate as this guy, which is 11, and the y coordinate is half the diameter, which is 5. 11 and 5. And this is the line that we're looking at, and the question is, what's the slope of the line? Well, let's find out. Slope of the line actually is simply rise over run, which is same as change in y over change in x. So what is the change in y? What's the change in y as we go from Q to S? The change in y is it goes from 3 to 5. So change in y is 2. Or actually, let's not be lazy. Change in y is 5 minus 2. 5 minus 3 rather. 5 minus 3. And change in x is 11 minus 3 again. And that's it, that's our slope, whatever that works out to be. 5 minus 3 is 2. And 11 minus 3 is 8. So it's 2 over 8 or 1/4. That's our answer. The answer is, slope of this line is 1/4. The answer is B. The answer is B. That's it. I will see you tomorrow when we will do the last 3 problems that you see there. There are 16 questions. This was number 13, which means we have 3 more to go. 14, 15 and 16. The last 3 problems that you see on the next page, we'll do them tomorrow because I'm saving them because they are pure hell. They are hard problems, or I should say supposedly. We'll see. I'll see you tomorrow, okay? Bye now.